Welcome to RK Tutorials, Solutions to Engineering Mechanics by Timoshenko, 5th edition. In this tutorial, we will discuss problem set to 2.5 and problem number 2.80. The ends of a heavy prismatic bar AB of length 2a and weight q supported by hemispherical bowl of radius small r as shown in the figure. Assuming the smooth surfaces, determine the angle alpha corresponding to equilibrium of the bar if small r is equal to 0.866a. Also find the reactions induced at the points of supports A and C. That means here you can see a hemispherical bowl. Half of the hemispherical bowl AC and full hemispherical bowl will be something like this. Now in that a prismatic bar AB is placed and this makes an angle alpha with the horizontal. The total length of the bar AB is given as 2a and let G is the center of gravity. Hence AG is equal to A. Our interest is to find the value of alpha for the system to be under equilibrium. Now first let us construct the total hemisphere. So this is the total hemisphere. Let us assume hemisphere. Now EC is the radius, that is small r. We know that G is the center of gravity for the bar AB. Hence the weight always acts from G. And let Q is the weight always acts from the point G. And you know AG value is small a. Now RA will develop at A, RC will develop at C. Clearly we can see RA is a point, hence the reaction at the A will be like this, passing through the point A. Now this is RA. These two forces must intersect at a particular point because the total number of forces acting on the prismatic bar AB are only three: RA, Q and RC. All three forces must intersect at a particular point. So I know the complete details of Q. I know the reaction direction RA. I don't know anything about point C. Now if you extend that Q, this is the extension of Q, and extend that RA, this RA passing through the point E, and these two must intersect at a particular point. These two are meeting on the circumference of the hemisphere. Now the third force RC must pass through this point and the point of application is C. That means the reaction at C must be along the line joining of CF. So this is the reaction of C direction. Hence along the direction RC value, this is the value of RC. Now clearly we can see that this RC is perpendicular to the prismatic bar AB, but this AB makes an angle alpha with the horizontal. Hence, the angle between these two will also be alpha because AB and FC are perpendicular. And this FG is vertical. Hence, these two angles, since angle between these two is alpha, their perpendicular angle must also be equals to alpha. Hence, this angle must be equal to alpha. Next, clearly we can see this line makes an angle alpha because opposite sides are same. So this angle must be equal to alpha because opposite angles are same. Look at the triangle ACE triangle. In that ACE triangle, EC is the radius of hemisphere. AE is also equals to the radius of the hemisphere. These two sides are same. Hence, this angle must be equal to this angle. Hence, we can find that this angle is also equals to alpha. Consider the right angle triangle ACF. Consider the right angle triangle ACF. In that, AF value is equal to 2R because AE is R, EF is R. So, AF is equal to 2R. and this angle is alpha and this is perpendicular. From the right angle triangle ACF, I can say cos alpha. Cos alpha is equal to the adjacent side. What is the adjacent side? Of course, it is AC. And the hypotenuse that is opposite to the right angle, that is AF. You know AF value is nothing but 2R. Hence, I can find the value of AC and you can say AC is equal to 2R into cos alpha. Similarly, by consider the same right angle triangle ACF, sin alpha also you can find. Sin alpha is equal to opposite side, that is FC by AF. Sin alpha is equal to FC by AF. Hence, I can find the value of FC and that FC is equal to 2R into sin alpha. Now, let us consider this GC. GC value can be calculated as AC minus AG. Now, AG value is no, because G is the center of gravity for the prismatic body AB. The total length of the AB is given as 2A. Hence, AG must be equal to small a. And AC value, we calculated AC value as 2R cos alpha. Hence, I can substitute here and you can find GC is equal to 2R cos alpha minus A. Now consider the triangle GCF. GCF. We can find a right angle at C. And you calculated GC. Just now you calculated GC is equal to 2R cos alpha minus small a. GC value you calculated. Hence, you can find tan alpha. Tan alpha is equal to the opposite side GC by the adjacent side FC. FC also you calculated from the previous slide. You calculated FC is equal to 2R into sin alpha. You calculated. Hence, I can substitute tan alpha is equal to GC by FC means 2R cos alpha minus A by 2R into sin alpha. Now, tan alpha you can consider as sin alpha by cos alpha. Sin alpha by cos alpha, and you can do the cross multiplication. So sin alpha by cos alpha is equal to 2 into R value is given as 0.866A into cos alpha minus A by 2 into R value 0.866A into sin alpha. So go with the cross multiplication. That means 1.732A sin square alpha is equal to 1.732A cos square alpha minus A cos alpha. This sine square alpha you can consider as 1 minus cos square alpha. So it is, you can substitute sine square alpha as 1 minus cos square alpha. You will get this expression. Then you can simplify. So this value is 1.732 minus 1.732 cos square alpha is equal to this much. So I can simplify. So after simplification, this is 1.732 cos square alpha plus 1.732 cos square alpha. You will get 3.464 cos square alpha minus cos alpha minus 1.732 is equal to 0. This is a quadratic equation in terms of cos square alpha. Hence, I can calculate cos alpha. You will get cos alpha is equal to 0.866 or 0.577 minus 0.577. By considering the positive value, I can say alpha value is equal to 30. This is the answer for the given problem. Our interest is also to find the reactions. Now, let us consider the free body diagram at F. How many forces are acting at F? The self-weight Q is acting downwards. So this is the direction of RA. This is the direction of RC. All three forces are meeting at this point. I can transfer all the forces onto separate XY plane. So this is the free body diagram at F I am drawing. So Q. So this is Q, I just transfer. Next one, this is RA. And next one, RC. Just transfer. Let us try to find the angles. Clearly we can see this angle is alpha. That means opposite side, this angle is alpha. Angle made by RC with vertical is alpha. Next, angle made by RA is required. Now, look at this triangle carefully. Consider the right angle triangle AFC. In right angle triangle AFC, here you can find 90 degrees. Here you can find alpha. So this total angle must be equals to 90 minus alpha. If the total angle is 90 minus alpha, this angle is must be equal to 90 minus 2 alpha. That means this angle. That is the angle between the RA and the vertical. These two are opposite side. Hence, this angle must be equal to this angle. This angle is 90 minus 2 alpha. Now, there are three forces. All three forces are meeting at a particular point. All three forces are divergent. Hence, I can apply the sine rule. So according to the sine rule, RC divided by angle between the other two forces, these two forces. What is the angle between these two forces? So the total angle is 180, 180 minus of this 90 minus 2 alpha. Hence it becomes 90 plus 2 alpha. Hence RC by sine 90 plus 2 alpha is equal to RA divided by angle between these two. Of course, it must be 180 minus alpha, RA divided by sine 180 minus alpha, and Q divided by angle between these two. So angle between these two is 90 minus alpha. Hence it is written as Q divided by sine 90 minus alpha. So by taking any two expressions, you can find the required value. Now take these two expressions. So you can say RA divided by sine 180 minus alpha is sine alpha is equal to Q by sine 90 minus alpha is equal to cos alpha. Hence you can say RA is equal to Q tan alpha, and we calculated alpha value as 30. So it is Q tan into 30. Tan 30 is 1 by root 3. Hence RA value is equal to Q by root 3. Similarly, by taking these two expressions, RC divided by sine 90 plus 2 alpha is equal to Q by cos alpha. Now sine 90 plus 2 alpha is equal to cos 2 alpha. Hence RC is equal to Q into cos 2 alpha by divided by cos alpha. Alpha value is equal to 60. Hence it is Q into cos 60 by cos 30. So cos 60, we can say it is 1 by 2 divided by cos 30, it is root 3 by 2. Hence we can say RC is also equals to Q by root 3. Hence alpha is equal to 30, RA is equal to Q by root 3, RC is equal to Q by root 3 are the answers for the given problem.